Meteorology segment for the day. Let's talk about snow and ice. Yes, snow and ice. Now, everybody's very scared and spooked by climate nonsense. What you're looking at here is a glacier, and this looks like the transition between a glacier and sea ice. One of the many things you may see on the internet attempting to frighten you into thinking that the ice is melting is you'll see videos of calving events where a glacier is falling into the ocean. You know what causes that, folks? It's caused by lots of snow and ice uphill from the glacier, the weight of which cause the glacier to be pushed into the ocean. It's called a calving event. It's caused by lots of ice. When a glacier melts, it recedes uphill to the mountain, because it's a river of ice, it recedes uphill like an evaporating river. It doesn't calve into the ocean. That's an indication that there's lots of ice. So that's just a preface to what we're talking about here. As here at the Smash News Network, we prefer to provide objective, reasonable information as opposed to climate nonsense, like certain organizations, CNN. So here's the first story. Earth's cryosphere is vital for everyone. Why? Well, the albedo effect. Gee, we wouldn't want too much sunlight to reach the planet. Boy, that would be very dangerous. Now, I don't know if you're aware, but you're actually living through an ice age right now, folks. Yes, it's true. You're actually living through an ice age. What is an ice age? Well, an ice age is defined when the planet has two icy poles all year round. Now, if you remember, back in the late 80s and mid-90s and so on, and even going on to this day, people have been forecasting an ice-free Arctic and Antarctic and catastrophic sea level rise enveloping cities and making the planet very, very scary and very, very spooky. You're living through an ice age currently because we have persistent ice at both polar caps. So let me just continue here. As we'll be talking about Earth's gravitational pull and centrifugal force and snow mass balance and all kinds of stuff like this. So let's read a quote from the article. Between 2003 and 2019, the Greenland ice sheet lost an average of 200 gigatons of ice per year, the researchers concluded. Antarctica's ice sheet lost an average of 118 gigatons of ice per year. The combined ice losses caused sea levels to rise by 0.55 inches over those 16 years, allegedly. Okay, let's talk about that. First of all, let's talk about the Earth's rotation. Earth's rotation has been speeding up. We've seen the fastest Earth rotation in 2020 that we've seen since the 1960s. And what's causing it? Well, the most likely explanation of what's causing it would be global cooling. Yes. Because, you see, when Earth's equatorial bulge shrinks, that causes the Earth to rotate more quickly, which means if the oceans get cooler, they recede as cold water takes up less volume than hot water. But also, when water gets deposited, instead of at the equator, it gets deposited at the poles in the form of snow and ice. Guess what happens, folks? The Earth's rotation speeds up the same way a spinning figure skater speeds up when she pulls in her arms. When the Earth's equatorial bulge shrinks, the Earth speeds up its rotation. Now, this is shown by the geologic record and by eclipse data. Here's an article about it, reconciling past changes in Earth's rotation with 20th century global sea level rise, resolving Monk's enigma. So perhaps check this one out. This one is from 2015, but there's all kinds of information you can find out about this, folks. So perhaps check that out. Next, let's check out the snow water equivalent. You can see the way this was 2 standard deviations above normal at the peak right around here in mid-March. Now the snow extent, which is just the square mileage that the snow covers, hasn't really been that high. It's pretty much been in the 1 standard deviation range basically the whole time, except during late October. But you can see it's been quite in the 1 standard deviation range, the snow extent. Next, let's look at the snow mass. The 2020 to 2021 winter was the 4th winter which featured at least some point 2 standard deviations above normal snow mass balance. So what is this deviation above normal? Well, this deviation above normal is, well, will you look at that? It's just about 200 gigatons outside of the 1 standard deviation range. And it's even more than that. I don't know, 400 gigatons outside the average, which is the dotted line here. So, oh no, 200 gigatons have melted from the Greenland ice sheet, which is where most of the snow... Is this making sense, folks? Anyway, here's the current state of affairs. This one is as of December 29th, 2020. What? What? All right, here's the Rutgers snow extent. As of, for goodness sakes. Is it going to show me a date? It is not going to show me a date. We'll just show you on windy.com. So before we go to nullschool.net and look at that stuff, let's go to windy.com real quick. And here's the current state of affair for snow depth. You can see Ohio, the entire northern half of the state is covered in snow, with several inches south of Lake Erie. Also, West Virginia's got some snow, most of New York. Half of New Hampshire, Vermont, Maine, all covered in snow. Even western Massachusetts has some snow. And let's get back to the regularly scheduled meteorology segment. So next thing we're going to look at here, folks, are the jet streams. So the reason it's so ridiculously cold in the eastern portion of the U.S., in fact, the entire 2/3 of the U.S., I guess you could say, is because we've got 2 different portions of frigid jet stream air pulling in. So you not only have this jet stream area here from central Canada pulling cold air straight down into the, into the Great Lakes region, but you've also got this air from British Columbia coming straight from the polar region and spreading some chilly temperatures. So perfect example of meridional jet stream flow. Also, look at these huge bends in the jet stream here in the northern hemisphere. The source of your cold temperatures. Here are the jet streams of the eastern world. Since we showed you the west, here's the east. And we'll show you surface winds as well. There are the surface winds. Has this system actually increased? Doesn't look like it has. It looks like it's weakened a little bit. I see 80-mile-per-hour winds. Looks like it's weakened a little bit. At least its connection to the jet stream has weakened a little. And we'll show the surface winds of the western world as well. There are the surface winds of the west. lightningmaps.org for a real-time lightning map. And by the way, I actually accessed lightning maps yesterday. I was in a thunderstorm, and I broke out lightningmaps.org. It showed me that the lightning was well north of my location and of no real concern. Real-time lightning maps at lightningmaps.org. Climate tipping points need not be the end of the world. Disastrous consequences could be averted. Whether it's the idiotic idea of carbon sequestration or the idiotic idea of solar atmospheric radiation, solar radiation management, whatever it's called, geoengineering to put dust in the stratosphere to reflect sunlight back into space, they're both idiotic ideas. The idea that man can control the climate is just absolutely ridiculous. If you know anything about the wattage requirements that are required to control the environment, whether it's through whatever idiotic ideas that you have that mankind can and is controlling the weather and indeed the climate is just absolutely ridiculous. It's a pathetic and putrid excuse. And it's ridiculous, nonsensical arrogance of the highest order. The idea that mankind can control the climate is absolutely idiotic. And here's an article about it. About climate tipping points need not be the end of the world because, we'll just control the climate. No big deal. Don't worry about it, folks. We'll just control the climate if we need to. A skill mankind does not have. Again, here's the current snow situation. Let's advance this till tomorrow. There's where we expect snow to be tomorrow at noon. Continuing on. Check out the weather.gov map. We've got freeze warnings. That's all those purple regions, folks. Frost advisories are these blue regions. Hard freeze warnings in Maine. Oh my God, it's so hot that it's cold, folks. It's so hot that it's cold. Here's your temperature anomaly. And these purple areas are like 15 degrees Celsius below normal. 15 degrees Celsius below normal. And let's advance this. Here's Friday, still cold. And by Saturday, we get more normal temperatures, but another ultra cold wave moving into Montana, North Dakota, South Dakota, and Minnesota by Saturday. Here's the current U.S. Doppler radar map, and we've got snow falling in Pennsylvania, New York, Maine, New Hampshire, Connecticut, Massachusetts, Vermont, Ohio, Indiana, Wisconsin, Illinois, Michigan, Iowa, Minnesota, Nebraska, Kansas, Wyoming, Utah, and New Mexico. Oh my God, folks. It's so hot that it's cold. It's so freaking hot that it's cold, folks. Stop the presses. Oh my God. Here's what's going on in the cloud layer. Better make the planet cooler, folks. The planet's not cool enough yet. We got to cool the planet off because it's so hot, folks. So hot. Cloud layer, water vapor map. A cloud layer, a water vapor. And once again, there's the U.S. Doppler radar map. There's the cloud layer. It's the NASA GOES 3.9 nanometer interactive weather satellite. There's the water vapor. And that's today's meteorology segment. I've been your host, Dan, a.k.a. smAsho. Thanks for tuning in. See you later, Twitch.